Hello, my name is Melissa Shepard, and I'm a technical architect, and I'm here to present to you a solution on universal safety. Universal Safety Technologies is a provider of safety and security systems to commercial customers. They have 150 offices across 15 regions in both the US and Canada. They provide services such as system design, installation, monitoring, and maintenance. They have 100,000 commercial customers with growth expected to be about 10% per year for the next 5 years. Currently, they are struggling with systems that are not well integrated. So some of the project goals and requirements are to create a more unified system by leveraging Salesforce, implement an API-led integration architecture, roll out to multiple regions, starting with one region first, and a phased MVP approach to reduce risk and increase project success, implement an agile project management methodology, and use source-driven development with source control and CI/CD. Some assumptions I've made are that the monitoring system APIs and ERP APIs support REST. Assumption that there is ADFS, since AD is their identity store, and that there are no budget constraints. Some risks are that there are dependence on an integration workstream. Timelines need to be aligned and testing using mock endpoints. They are geographically separate IT teams, and they're trying to ask for a 4-month time frame, and management wants to release all regions within this time, so we need to negotiate a phased MVP approach and explain this will be lower risk with higher project success. Some of the strategies we will use are a single org strategy, which will provide a 360-degree view of the customer, unified business processes. I didn't see any data residency requirements, and everything fits well within system limits. We can support this using things like page layouts, record types, sales and support processes with pick lists, and profiles and permission sets for data visibility. This will create a more complex security model. And we'll need to support the single org through governance and standards. We can also have delegated admins for different departments with one super user to oversee the entire org. We'll also have governance for the differing business processes and try to maximize reuse of code and declarative functionality. We'll also have to support multi-currency and multi-language. They mentioned they want to support both English and French, so we'll use the translation workbench. For communities, we'll export and then translate and re-import for navigation. We can also enable different languages within the community and provide a language picker for customers to choose their own language, and also use Visualforce email templates. We'll also enable multiple currencies, both US dollars and Canadian dollars. For identity, for the internal users, we'll use Active Directory, and I'm assuming we can use ADFS with some just-in-time provisioning. For external, the customers will use social sign-on. We'll have to create auth providers and registration handlers for each auth provider, and then for contractors, they're just going to be using username and password. For mobile, we'll make use of Salesforce One for internal employees. It's faster time to market. I considered custom, but didn't see anything such as pixel perfect UI or full offline capabilities, or any background processes that need to run. For external, we can use Mobile Publisher to extend the experience site access to mobile. This is also faster time to market. Also considered custom here, but didn't see anything that would push me towards that where they needed full offline capability or any pixel perfect UI. So this should suffice. For document management, I calculate about 7,300 gigabytes of storage, so I feel that this is sufficient for our file storage. We can also archive files to S3, Amazon S3, when we'd archive data, and I'm proposing to use AWS for data archival, so we can use the AWS stack for both things. Reporting, we can use Tableau CRM, which can connect to multiple data sources and also support historical trending. It has more advanced analytics, especially for management. And we also can make use of standard reports for simpler reporting for platform users. Some add-on licenses are Service Cloud Voice with Amazon Connect, digital engagement to support SMS, and possibly live chat, DocuSign for document generation, as well as eSign, and then Salesforce Connect for OData to expose data as external objects. And here are the calculations I did for the files, also some data storage, which that should be sufficient. Actors and licenses, we have system specialists. They will have a Service Cloud license. Some considerations here, they'll be dealing with orders, work orders, Service Cloud Voice, also digital engagement. Support reps, also service. They'll be dealing with cases, omni-channel, Service Cloud Voice, digital engagement, like also likely some work orders. Office managers, they can just use the sales Cloud license. So with Service Cloud, we do get some sales licenses, so we don't need to assign them as Service Cloud users. They'll just be accessing the CRM functionality as well as Tableau CRM for reporting, and probably some standard platform reports. Regional managers as well, same Sales Cloud license, CRM functionality, reporting, and the same with the HQ managers. We'll also have some external contractors. I'm proposing Customer Community Plus. They'll need experience site access and some advanced sharing. Some primary customer contacts, also external Customer Community Plus. They will need to have, they'll need to have experience site access. They'll need to manage cases, and also we'll need to give them delegated admin. And then secondary customer contacts can just use the Customer Community license site. I only saw that they would need experience site access as well as the mobile for both kinds of contacts, but nothing such as delegated admin or advanced sharing. Next, we'll go over the system landscape. So I mentioned we're going to use auth providers for customer users. So this will use an OpenID Connect OAuth flow to authenticate to Salesforce. We'll also have a public website that is, hold on, let me try to this bigger. Sorry, it's not going to work. So it's hard to read. So the public website, which is going to be used for lead capture. So with the web to lead, we can use the standard web to lead form with reCAPTCHA to prevent against bots and spam. So this will use one-way TLS to connect to Salesforce for the web to lead form. It also needs to expose some data for reporting purposes. So we can connect the website to the ESB to retrieve data from Salesforce using the REST API. We also have our mobile apps. The internal app will use user agent with SAML, and then the external app will use user agent with OpenID Connect. Amazon S3 for data and file archival, and we'll be using our ETL for those processes. So we're going to be using the ETL for bulk loads, any scheduled jobs of large amounts of data. Also for initial data loads, extracting, transforming, and loading our data, especially in our data migration processes. We'll want to make use of the bulk API 2.0 as well as REST API for files. We also are going to be retiring a couple of systems. So we're retiring the CRM system. So we'll want to be migrating data from the CRM using our ETL, and we'll secure our ETL communication with Salesforce using a JOT flow as well as mutual TLS. And Salesforce will be the system that's going to enforce that mutual TLS with the ETL, because the ETL will be the system calling into Salesforce. We also need to migrate some files from a design tool, and we can use ETL to migrate those files from a central file location. We also will be implementing an ESB. So ESB will provide more of the real-time ongoing integrations, so it can provide transformations, automatic retries, orchestrations, error handling, and protocol conversion for things such as OData. It also can provide aggregation for APIs, a decoupled integration architecture, and guaranteed delivery, as well as that API-led approach that I mentioned before. So they do have Active Directory, so I'm making the assumption here we can use ADFS, and we can make use of just-in-time provisioning. We can use a federation ID to match the users between Active Directory and Salesforce. We'll have to get the IDP certificate and bring that into Salesforce to create an SSO setting for our single sign-on. And this will also provide for SP-initiated SAML with tape linking, which is mentioned as one of the requirements. They also have some other on-premise systems. They have multiple ERPs and a few monitoring systems. So this is where I'm making the assumption that those are we can call into them using REST APIs, and they also have devices that are sending data to the monitoring systems. I have got a couple of our identity flows. We can go over these later. Data JOT bearer and user agent with OIDC. Here's the data model that I'll explain that will support the business requirements. So I'm proposing just a standard account contact model. And we'll be using leads for web to leads. So prospective customers will come in as leads, and then once they're qualified, they'll be created as accounts, contacts, and then orders. And then we're going to use Salesforce for our pricing for the orders. So we'll make use of price books, products, and price book entries. It also mentioned that there are different locations where devices are installed once they are purchased. So we'll then create the locations associated to the accounts, and then there's some more functionality that's supported through creating assets once the assets are installed at the location. So we'll have to create those asset records and then associate to them to the correct locations for the customer. There's also installation and maintenance that needs to happen. So we can have two different kinds of work orders to support those processes, both the installation and the maintenance, and then work order line items that can be associated to each asset that gets installed. And then there's also maintenance schedules that need to be associated to the assets, so that will tell us when maintenance is due. Also, making use of cases to report issues. So they did mention that there will be quite a few cases that get created. This is where I've identified some LDV. So we can archive those cases once they are closed and not operational anymore and re-expose them as an external object. The asset is an area that is LDV. I considered using external objects, but assets don't have implications on system storage. And I've thought that we could probably manage the LDV, keeping them on platform by assigning a system user, so we wouldn't have to, that's not in the role hierarchy, so there wouldn't be sharing calculations that could affect system performance or CRUD operations, and it's more for reference data. So there is also the option, if there are any issues here, to move those off platform. Also, it does mention that they want orders from the ERP to be, all the details to be exposed in Salesforce, so we can expose those as an external object. And since there's multiple ERPs, we can aggregate the orders into one external object with one external data source connecting to the ESB, which then will connect to the different systems. So we don't have to worry about multiple external objects. The role hierarchy to support the data visibility, starting with the CEO and then a VP, and then there are different headquarter managers, regional managers, also then office managers. So system specialists will be reporting to the office managers. The primary customer contacts will be dealing mostly with the system specialist. So their accounts will be owned by the system specialist. And then they mentioned there's 3 different support centers, 2 in the US, 1 in Canada. So those would be reporting to the headquarter managers, and the support reps will be working with the different support managers, and then contractors reporting to the support reps. Some of the calculations I did for LDV. So the devices are about 32 million. So short term, we can have a system owner, as I mentioned. So we can have SOCL and this using index fields such as asset name, account, lookup, serial number. So we want to make sure we're also using selective SOCL. We can also make sure any of our processing is asynchronous where possible. So like updating any related objects. We could use platform events. Same with cases. Since this data is operational, I'm not really going to recommend skinny tables here because that they can actually be a bit detrimental, and they're really only good for reports and list views. So for cases, we can use SOCL and list views that are using index fields such as status, record type, owner, case number, etc. Any of the standard index fields I think should suffice, and then we also can use async processing here as well. Work orders, they said there were about half as many work orders as cases, and there's also going to be the installation work orders. So this is a number that could start to get towards LDV territory around after 5 years, maybe 5 or 6 years. So this is something we would want to keep an eye on. It could have some impact. We could make sure to be proactive to be using index fields in our SOCL and list views, such as status, owner, number. And then for long term, for the devices and cases, the devices, I did consider moving them off platform and exposing them as external objects as reference data, since they do not contain any sensitive data and there's no clear security requirements for them. So that is an option. And then also for cases, I would propose archiving them off platform once the cases are closed, and maybe after a month or so, however long we determine what the business is good, to move them to an archived system, and then we can re-expose them as an external object and link them to the account. So some of the considerations with LDV are that keeping large volumes of data on platform will affect the overall system performance, such as CRUD operations, reporting, list views, record locking, and sharing calculations. So next, I'll go over more of the business processes. So first is sales and design. So the customers can call one of the numbers on their website or submit an information request on the website. This is where they'll come in as a lead and we'll give them whatever information they need. And then the support representatives will be assigned the lead. So for calling, we can make use of Service Cloud Voice with Amazon Connect. For the information request, we can use Web to Lead from the website. So it was about 167 per day. That's under the 500 Web to Lead limit. And we can assign leads using Omnichannel. And then once the lead comes in, the support rep will pre-qualify them using a questionnaire. So we can give them a lightning flow to give them a custom wizard style questionnaire. And then if they are qualified, they'll then convert the lead to an account contact and then an order. And then there needs to be a site visit by a system specialist so we can create an event associated to the order and also assign it to the system specialist. And then they'll need to take pictures and videos while on site. So they will take those pictures and with their mobile phone and then add them onto the order using the files relayed list. And then we'll create the preliminary estimates and send a copy to the customer. So they'll create a draft order as the preliminary estimate. I'm proposing that we just use the order here for all the estimation and visiting of the customer. So they'll then create a contract using DocuSign DocGen and send it to the customer for review. And then they do want to also capture GPS information while they're there, so we can give them a Lightning Web Component that uses a JavaScript library that imports that library, and then they can click a button to capture the geolocation and then save the coordinates on the location record associated to the account. And then the creation of the estimate activates a process for the customer to view the estimate in the experience site. So we'll have to onboard the customer once they're converted, and then we'll enable them for community access, and then they'll receive an email with login info to log into community and also to download the mobile app. So once they set their password or choose to use social sign-on, they can log in and then collaborate on the order. And then it mentions that there's design plans also that they'll be attaching to the orders. They can be up to 100 megabytes. So this is under the 2 gigabyte file size limit. So this will be fine to be stored in the files related list. And then once the design documents are created, the customer will be notified, and then they will collaborate with the system specialist and digitally sign the estimate. So they could just use Chatter on the order to collaborate, and then the design file will be attached to the order for the customer to access. So they'll have to share that file to give the customer access, toggle the customer access on the sharing for the file, and then the order will get updated, and then we'll create a DocuSign document to send for e-signature. So if there are any changes, it will just generate a new document for them to look at and then sign. And then the customer also has to provide some financial information. So there's some sensitivity around this. This is where I'm proposing we store the financial information into a separate object so that we can control visibility easier. And then there needs to be an approval process once the order is submitted for the regional manager to the local manager to approve. And then if the cost is over a certain amount, the regional manager will have to also approve the order. So we can use the user's manager on the manager lookup on the user record. And then I mentioned before, the customers will be able to use their social sign-on to sign into the experience site. So once this is done, then the contractors will need to be assigned to go on site and actually install the devices. So it mentions that contractor accounts need to originate from the ERP. So we have an integration here where contractors are created in the ERP. This will be a remote call-in via the REST API using the Salesforce connector. ERP updates received by the ESB. ESB will pull for changes daily because it mentions that it only needs to be on a daily basis, and then update Salesforce with the contractor account creation and updates. So these accounts will be locked in Salesforce for users except the integration user. And then if it's a new contractor, we'll have to have a automation that runs to create their community access, and they'll receive an email with how to log in and set their password. It mentions they're just going to be using native credentials, so no special identity here for them. And then once the contractors are in the system specialist will select the contractor to do the installation. So there'll be a lookup field on the order for the contractor, which the system specialist can populate. And then we'll have to give them visibility to the order using a sharing set where the order contractor equals the user contact. And so the contractor will then review all the documents in the order. They will also need to collaborate as well with the system specialist, so they could just use Chatter there as well. And then if there are any changes that need to be made, the system specialist will have to make those changes. And then once the contractor accepts the design, they can click a quick action to accept, and then we'll have a checkbox on the order for contractor approved. And then once this happens, we'll have a record trigger flow on the order to notify the system specialist that it was accepted. And then the contractor is also going to have to sign a contract. So this can just be a contract template through DocuSign that they e-sign, and then we can attach it to the contractor's account. And they will be notified through email, custom notification, or the system specialist would be notified upon document signature. We can use email, custom notification, or chat or post. And then once the order is created in Salesforce and it's flagged as complete, we're going to be sending this to the ERP system. So we have another integration here. Salesforce will call the ESB, which will then call the ERP. This will be process invocation, fire and forget platform event. And I'm proposing platform event here because we can make use of the standard platform event on the order status change. So we can easily subscribe to that and then sync the account and order at this time to the ERP using an ESB orchestration, which will decide which ERP to sync with based on country. So I did consider change data capture, but for orders, we do have the standard platform event that we can use. So this also is an asynchronous integration because we do not need immediate response for the user. And then detailed order data in the ERP should be viewable or accessible from within Salesforce. Is what we're proposing. We use an external object for the order, and then we can relate that to the Salesforce order, so they can just click on the related list of external orders and see the details in the ERP. So we're going to virtualize the data there. The ERP then needs to update the order status in Salesforce once the items arrive at the location. So the ERP would then send a notification through the ESB to Salesforce using a remote call and REST API through the Salesforce connector. And then Salesforce update the Salesforce order with the associated ERP order status. And something I didn't mention is, I didn't call this out, we are going to use the streaming API. And that's going to use subscribe to a streaming event channel. And I think my system locked up.
I think your timer is locked too.
Yeah, that's it. I'm done. Well, so much. All right, let me figure out where I was in here. Okay, I think I found where I was. All right, ready for me to start again?
Yeah, go ahead, yeah.
All right. So during the installation, each device is added to the customer installation. So this is when we have another integration. The monitoring system will notify the ESB, and then it needs to link the device with the correct customer in the correct location. So we'll have an ESB orchestration here where the ESB will call to the ERP to figure out which customer and location this device belongs to, and then create the asset record in Salesforce for that device and associate it to the correct account and location. And the account association will be through the location. And then once the installation is final, the contractor will update so this is when the contractor is assigned to a work order. So they'll create a work order from the order. The work orders to represent the on-site work so that we can have the work order line items, because if we have multiple devices, we'll want multiple line items associated to each asset. And then the contractor will update the work order status to complete. They can do this all from their mobile publisher app. And then the system specialists will then be notified that the work order has been complete, and it says that the system specialist will then update Salesforce, so they'll update the order to complete. So this would also trigger another integration here. So Salesforce will Salesforce will notify the ERP using remote process invocation, fire and forget. We can use a platform event here. This is another standard platform event on the order status change, and the ESB will figure out which ERP based on the country that it needs to update. And then the ERP will then create the invoice. And then the ERP can then update back into Salesforce using a remote call-in. And this also can be asynchronous. It didn't say that there needed to be a real-time update back to the user. So the ERP can update back to Salesforce using the REST API and the Salesforce connector through the ESB, and then update Salesforce with the invoice number and final amount that can go on the order. Then there's some scheduled maintenance that needs to happen. So this is where we'll use the maintenance schedule associated to the asset. So when scheduled maintenance is due, about 1 week away, a service order should be created in the ERP system. So we can use the ESB, which also has ETL capabilities, to create a nightly batch job to run, and then check the date to see if any maintenance, it's 1 week before maintenance is due. And then if it is, create the sales order in the ERP. And then this is an integration here where the ESB will be querying Salesforce, remote call in using the REST API. And then when it determines that we do need to create a sales order, the ESB will make a call to the ERP, which it can create the sales order and update back to Salesforce to also create an associated work order. And that will tell us that we need to assign a contractor to then perform scheduled maintenance. And then once the maintenance is complete, the system specialist will then update on their mobile device and the status of the ERP service order will be updated on a real-time basis. So once the work order status is complete, first we have the user agent flow here with the mobile app to Salesforce. That's when they're going to update the work order. And then we have an integration from Salesforce to update the ERP through the ESB. We can use a platform event here as well. Record trigger flow on the work order status update, which that flow will then create the platform event. And then the ESB will be subscribing using the streaming API. The ESB will have the orchestration and then update the correct ERP service order to complete. There's also monitoring and issue management. So this is while the devices are being used by the customers. So customers can, so issues actually can be raised from the monitoring systems themselves. So if any issues are detected, the systems can make a real-time API call when certain events occur. So these events should create a task associated with an issue within Salesforce. And then the support representative will need to call the customer and handle the issue with them directly. So the monitoring system will call the ESB, which the ESB will call Salesforce through a remote call-in using the REST API. The ESB will create the case in Salesforce when notified by the monitoring system, and also create a task related to the case and assign to the support queue. And then any available support rep can take that case off the queue. And then customers can also raise cases themselves, so they can log into the experience site with their credentials and create a new case, and then to associate it to the correct asset, there'll be a device lookup on the case. They can also use their mobile phone through the mobile publisher app. Also, it mentions they want them to be able to scan a barcode, so we can create a barcode field on the asset, and then when the customer that will be stored on the asset record. So when the customer scans the barcode on their device, they can use the Lightning Web Component using a JavaScript API, and then that will match with the barcode on the asset and then auto-populate the asset lookup on the case. And then it mentions that issues submitted this way should be routed based on geography and expertise. So we can use omni-channel skills-based routing here. But first, the queue will be the case will be assigned to a geographical queue. So we can use case assignment rules here to determine which queue the case needs to be assigned to. And then once the case is assigned to a queue, then the skills-based omni-channel routing will kick in and determine which rep will be handling it based on their expertise. And then for maintenance, if maintenance or repair work is needed, the support rep will create a maintenance task. So this is where they would create a maintenance work order, and then that work order would need to be assigned to a contractor to handle it. There's another integration here. Salesforce will call the ESB, which will call the ERP. This is another remote process invocation. This is a request and reply pattern, and I'm proposing that we use Lightning Web Component with Apex here, with an Apex controller, because they want immediate feedback of success or failure to be displayed to the user. So we can give them more of a rich experience using Lightning Web Components. And this will then create the sales order in the ERP. So we can have once the work order is created in Salesforce, that will initiate the call to the ESB to create the sales order in the ERP. And we can also make use of the continuation server for long-running callouts in our Apex. And then issues that are created by support reps. This is when customers will call the support center. This is we'll be using Service Cloud Voice and then omni-channel to route the call. So we'd actually have to use Amazon Connect Lambda functions and contact routing for the actual routing. And then once it figures out where it needs to be routed to, the call would be assigned to a queue, and the agents can use omni-channel within the service console to accept that call. And then the support rep will just create a case in the service console and relate that to the customer account and the device, and then create an associated work order. This is where it mentions that there are about 20 issues per year to be tracked. This is where I determined that we have the cases LDV, and because there's about 200,000 locations. Let me find that. And yep, so it's going to grow to about over 300,000 locations. So that's where the cases are going to be growing. So there's about 20 per year being created per location. Next, we'll go over some data and migration. So this is what I'm proposing for the data and files archival for our long-term LDV strategy. We would be archiving data using the bulk API, using the ETL, which would push the data to a data warehouse such as AWS, which I'm proposing. And then once that data is verified, it's made it there, we can hard delete the data from Salesforce using the bulk API. And then for files, we'll want to migrate the files associated to that data using the REST API. From the content versions and the content document link, we can also use the ETL. We'll push that to Amazon S3 buckets where we can have a folder name that's associated to the record ID in Salesforce. Once the files are verified, we can then have an ETL job that goes back in and hard deletes the content documents using the bulk API. For data migration into the system, we were going to pull data from the leads. So it mentions that customer leads for the last 5 years need to be brought into Salesforce, but also if they are not in the ERP system. So we'll be bringing data in from multiple systems into a staging database using our ETL. Things such as accounts, contacts, locations, sales orders, service orders, products from the ERPs, and then leads. So we'll have to determine some deduping logic. We'll have to work with the data architects to determine this, but we can use things such as first name, last name, zip code, phone, email, and any sort of combination of those to dedupe our leads against ERP contacts. And then any leads that are not existing customers in the ERPs, we'll bring those into Salesforce. So any historical or inactive data we'll want to bring into our data warehouse. And first, we'll want to bring the data, though, into a canonical DB, which will represent our Salesforce object schema. So we'll want to do some mapping and transforming, work with the data architects on that as well. And then we'll want to match our children records to the parents using the external ID. So we'll want to use a specific order of load. Oh, I forgot to mention, we'll also be bringing in devices from the monitoring systems, and we'll have to, the existing devices, we'll have to match those to the correct accounts and locations using external IDs. So the order of load will be leads, accounts, contacts, and then the locations associated to those accounts. And then we'll also probably want to bring in some products, since we're going to use Salesforce as our system for sales and pricing for these orders. And then we'll want to bring in the devices and then any sales orders and service orders last, because those are going to be dependent upon accounts and products. So then any data that we do need to keep operational in Salesforce, we'll bring into sandboxes first, such as QA, UAT, and staging. We want to do our full testing in our staging database. We can make use of Salesforce data masks within our sandbox environments to protect any PII or sensitive data, especially for developers that don't need access to the actual data. This will obfuscate and scramble data for us. And then here's our files migration for the desktop files. So what we'll want to do is copy all the desktop files to a central file server, and then we'll want to use our ETL using the REST API to push those files into our staging database first to make sure that our ETL jobs are relating the files to the correct accounts. And then once we feel that's good and we've tested, we'll then push all the files into production after we've done our data loads. And we'll do this by by creating content versions and also setting the first published location ID, which will be the record that we need to associate the files to within Salesforce. And for our initial load, we can just keep the OWD open and then set our security after the load so that we don't run into any issues. And I'm proposing an iterative load. So starting with an initial data load and then doing iterative delta loads within migration windows. This will just cut down the risk as we get closer to go live. So I'd rather do the initial data load, the largest one earlier on, and then do just smaller delta loads to reduce the risk of having any data issues, because there's usually issues that can happen around data and importing data within the Salesforce. And then once we do set our security, we can use a custom permission for the integration user to bypass processes and validation. So it mentioned that the last 3 years of sales orders and service orders, so that's the data that we'll want to bring in from the ERPs, and then all the devices will be migrated as assets, and then I went over the files migration. So we'll associate those design documents to the correct accounts. So some visibility and access requirements. So system specialists should be able to view and edit all customer and installed system data for their own customers. So this would just be ownership-based sharing, and they'll have edit access on their profile for accounts and contacts. And then the system specialists also should be able to view all customer and installed data for other specialist customers within their local office. So this would be ownership-based sharing with the office role, the role hierarchy. And then if they don't own the account, they would only have view only on the sharing role. And then for the financial data, the ownership will be synced to the financial data object. So if they're the owner, they'll have visibility. If they are not, they won't be seeing the financial records. All managers should be able to view and edit all customer and installed system data, including the financial data. So this will be through the role hierarchy. So and then we can share with other managers in different roles in the hierarchy through ownership-based sharing. The contractor should be able to view and edit data for the customer locations they have been assigned. So I'm proposing we use Apex sharing here to give them access to the specific location records associated with the assigned work orders. And then customer contact should be able to view and edit only their own customer contact and installed system data. So this is the community users get access to their account and contact records. We can create sharing sets to give view and edit access on the account and assets for the user. Contact at account equals account ID, as well as location account is the account, the user contact account, and also the asset account lookup can use that same lookup. But then there are also certain customers that have an account hierarchy. So the primary contacts will need to be able to see all location and subordinate data across all related accounts. I did consider external account hierarchies here, but that doesn't really give much sharing unless there's ownership of records within the hierarchy. And I'm not proposing that any external users will own records. So we can make use of accounts with related contacts. So we can relate those primary customers to all the child accounts within the hierarchy. And then we can just set up the parent lookup on the account field to know which account is the parent account to create those lookups. We can then create sharing sets using the related account, the contact.related account for the profiles for the primary customer contacts. So it would be a different sharing set for them for their specific profile. And then support center representatives should be able to see all data within their geography. So we can use the role hierarchy here with the ownership-based sharing based on roles that align with the geographies, and the financial data would be private, so we wouldn't be sharing that with them. Some reporting requirements are support reps need to be able to see all sales activity for customers they have access to. So I'm proposing we have orders be controlled by parent. And I'm proposing that we use the principle of least privilege. So we're going to try to use private as much as possible, but make use of control by parent with asset and order to give visibility to those records. So if they want to run a report, if they have access to the accounts, they'll be able to see the orders. And then also for cases, support reps, system specialists and managers should be able to run reports showing number of device monitoring events for customers they have access to. So device monitoring events would be cases. This would just be a standard report, and they'll get implicit sharing with access to their accounts. Managers should be able to run ad hoc trending reports. This is where I'm proposing Tableau CRM for historical trending. Due to the volume that historical trending creates, we don't want to do that on platform. And we can also connect to monitoring systems to combine data if necessary, if they want to see details. Customer contact should be able to run reports showing issues in their status. It's just be a caseless view in the experience site. And then they also mentioned that they want a report to be run from the public website. And this is where I'm proposing that the website can call the ESB to then call Salesforce REST APIs to return data to display on the website. Some project and development requirements. It mentions that I went over this, English and French will be supported through multi-language. I also want to bring in a formal DevOps process. So I would like to make use of source-driven development here. It does mention that there's multiple geographically separate IT teams. So this is how we'll make sure they're not overrating each other's code and that they're able to work more seamlessly and not in silos. So they'll work in their own dev environments. They can make use of VS Code with SFDX plugins. Also for code quality, PMD with rules, and also ESLint, Jest, and Apex test to test their Apex and Lightning Web Components. Mentioned before, mocks and stubs for API testing, and SonarQube for static code analysis. So once the developers are ready to start doing some work, they'll branch off the develop branch, create a feature branch for the story they're working on. I'm proposing agile project methodology. And then when they're ready for their code to be merged, they'll do daily commits to make sure their code is up to date and also sync with the dev branch. But once they're ready, they'll submit a pull request for code review, and then a more senior developer will review the code to make sure the business requirements are being addressed within the code. And once they feel it's ready, they'll merge that code into develop, and then that will kick off a Jenkins CI/CD pipeline job, which will then push it to the dev environment to be where the code will be integrated, and smoke testing of the build will happen, and regression testing to make sure that nothing is broken. If the build does break, a failed build notification will be sent to the developers so that they can fix any of their issues. And then from there, we'll want to move the code to a QA environment, which would be a Dev Pro sandbox. We want to do some Selenium testing here for functionality, regression testing, and then also manual test scripts determined by QA. And then once we're ready to move the stories for user acceptance testing, we'll go to the UAT environment where the business can then test. We can also set up functional tests with Selenium, and then we'll move it to a full staging environment where we'll do end-to-end integration testing. This is also where we're going to do our data migration testing, and we can also do performance testing using something such as Load Runner, opening a case with Salesforce a couple weeks before our planned performance testing. And also we can set up Selenium tests and staging as well. And then once we're ready to push to prod, we can run smoke tests on the code and data in production. And Jenkins will also run the automatic builds and also run Apex tests. And then if we need to, we can create a hotfix branch for any issues in production. So once the hotfix is ready, we would push it to a Dev Pro sandbox for some testing. And then once it's deemed acceptable, move it to production. And then any hotfix code will need to be merged back to the develop branch so that developers can then receive those updates in their feature branches. And then I'm also proposing more of a COE type of governance body. So I mentioned we're going to use Jira for stories, and we'll bring stories from the backlog and prioritize them into 2-week sprints. So because this is a 2-week or a 4-month timeline for the initial MVP, we'll want to work in more of an agile methodology. So we'll have daily stand-ups, sprint planning, sprint grooming, sprint retros. We'll want to use Confluence to document standards and any APIs that we're building. So yeah, I'm proposing the management wants to release to all regions in 4 months, and I don't agree with that. We really need to use a phased approach. And then they want their recommendations on how to manage the project. This is where I'm proposing that we use Agile, and because of the geographically separate IT teams, we'll want to make use of a PMO office to coordinate between the different teams, also business analysts to make sure that we're determining the right business requirements that need to be developed and implemented in the system. And then change management for adoption, communication, and training. And we'll have different work streams for the project, such as the platform, data, integration, and mobile. And we also want to make use of a compliance and data privacy to deal with things such as CCPA. And I believe that's all we have in the project and development requirements. So now I'm ready to answer any questions. Thank you.